So today we are going to discuss the multi-factor authentication and the web authentication, the newly introduced web authentication API. So why we need a second factor to authenticate users? Why are passwords not enough? So basically, because passwords can be key locked if you are sitting in somewhere public and you are using the PC. If this PC, since it is public, it's not yours. If it has a key locker application, it will pick up your username and password. And once this is done, he will have the full access to any service you are using, like it is completely you. It can be phished. Like we are having these new messages now, even on WhatsApp, saying that your bank card has been blocked and you need to call the bank on this number, which is completely phished number, to get more information from you. And it can be repeatable, which means that, for example, most of us use one or two passwords across different services. So if, for example, your Gmail password is hacked, this means that with high probabilities it is the same password like your Facebook password. So now most of your services are completely in the open. So there is a well-known security principle that the user should be identified by three different things. Something he knows, which is the password. It's only in your mind, you only know it. Something he has, which should be a security key, and something he is, which should be a biometric like the retina scan or a fingerprint. So we make sure that this is the user we really want to make, that he should have access to the service. So the MFA is the process of asking the user to prove his identity using another verification method after a correct password. Technically, there should be two ways of doing this. Either using a custom MFA device like the one shown here. This is the one which has been used by PayPal for some time. So whenever you want to have an access to the second factor authentication, the service provider sends you your own security token, and you have to use it once you need to log in. Or the one-time password which can be sent to the user email or the phone. And we in Saudi Arabia will known to this method. Once we need to connect to login to our banks, we get an OTP on our mobile phones. But technically speaking, these two methods are a little bit expensive because I cannot provide a token for every user if I have a multi-million user application. Or at the same time, using the SMS gateways, the banks I know is paying millions of reals per year just for the service provider to use the SMS. So let's discuss some cheaper methods to have the MFA in our applications. Technically, there are two sets of softwares that can do this. Let's start with the cheapest one, which is available for free, which is the authenticator apps like the one shown here on the image below. And it's popular with the smartphones, and it can register multiple services at the same time. And one of the most common known application for this is the Google Authenticator and another application called UC. So this is the most free one. And there is another one a little bit more expensive, which is the security keys, which we have here on this table. It is a special purpose USB devices that can be used with multiple services at the same time, and the user can register multiple ones on the service at the same time, which means I can have a couple of these, one on my keychain and one in the office. And if I arrive to the office, I use this one, and when I use my outside, I can use this one. So we can have multiple. And the most famous ones are the Ubiquitous. This is a golden standard in the market, and Google has one called Google Titan. So this is the Ubiquitous. So let's see how we can use authenticator apps. So authenticator apps, every one of these has two phases. Something for the registration phase. You just registering your second factor authenticator, and authentication phase. For the registration phase, the user can scan the QR code, or if he doesn't have an image scanner, a camera, he can just enter the code. And the authenticator app will generate a 6 digits codes to him, and as shown here in the image, the user should provide the 6 codes that have been generated by the scanner, by the authenticator. As the authenticator time, things will be a little bit easier. As the authentication, as the user logs in, the app will ask the user to provide the displayed code on his authenticator. So the user will just open the authenticator, find the correct service here, and just enter the 6 numbers and click submit. The pros of this service is shareable between devices, which means that if I have two or three phones, I can I have this on all my phones and all my devices at the same time, so I can log in using any phone, and there is no network connection. So if you are sitting in an external data center which has the mobile service down, like we are sitting here, we can just log in using the auto-generated code. So the question is, what happened behind the scenes? We are technical people at the end. So the QR code contained a random seed. This is what we entered in the authenticator. And using the Unix timestamp and the seed, the HMAC algorithm generate a 6-digit passcode. Okay, so we have two information. Everybody knows what is an Linux timestamp is. So we have two numbers now. We have the seed and we have the number. Using these two values, we generate a one-time password for this key. So when the user clicks the submit button, the server, it checks the received code against the code generated in the last 30 to 60 seconds. So we have to do the loop different times. So now we have the code 1, 2, 3, 4, 5. Technically on the server, the server have to check if this code was available in the last 30 to 60 seconds according to the window defined by the service. If no match, then the service will return an error that this is the wrong code. So this is the authenticator apps. It is very easy to integrate. It's one of the simplest methods, but the problem of this that it's shareable. In health informatics, data should be private because we are dealing with private patient information. So we need to make sure that the data that the user is trying to log in is really the user who is trying to log in. He cannot send his username and password because it is well known between physicians that they share. It is common sense for them to share their medical system username and password with the nurses, with everybody. This is causing us a crisis now. So we need to be able to make sure that we have something in possession. That's why this is very beneficial for us. And this is why the rest of the discussion will be about these things. So for security keys, we have several protocols to interface with these ones. One is called the one-time password protocol, and the other one is called the universal second factor protocol. The OTP is a manufacturer specific, which means if I get the Yubico one, it will be different from the Google Titan one. So it's completely out of scope for us because this is not the standard. We will work with the standard. It will be much easier for everybody. So the UTF protocol was developed by Google and Yubico with a support from NXP. NXP is a semiconductor manufacturer which is well known. So they were working together to find a protocol that will make things like for everybody. And this security protocol should work under a secure context. So for the first phase to be able to adapt these things, that you need to make sure that you are serving the application under HTTPS. So which services currently support the UTF protocol? As you see, most of the well-known services, Google, Facebook, Microsoft, Twitter, Dropbox, Amazon, as the AWS is supporting it, even the OS now. So you can just set your OS to be able to log only if the key is present. So on your Windows, on your Linux, on your Mac, you can just make sure that you log in using the key. Okay, so technically speaking, what is the UTF protocol? It's a standard protocol for the communication between the security keys and the web application. The idea in the security key is that we have to generate a public-private key for each service, which is called here the relaying party. So we will use this definition a lot. The relaying party is the service provider. And to prove the user identity regardless if this key is connected through USB, NFC, or Bluetooth. So here is the registration phase. We agreed that every time we are going to discuss something, we will discuss a registration phase and a authorization phase. So things will start as the relaying that client, the browser, will ask the relaying party to initiate the registration phase. So the relaying party will send an app ID and a challenge. A challenge is a random seed that has been generated on the server side for this request. So here the browser will be responsible about checking that the app ID, which is in this message, is the same as the domain we are using. So for example, I cannot be using www.saudijenomeproject.com and I'm saying the application ID is google.com. The browser will reject because the message, the URL we are on is different from the one that the server is trying to register. So if everything is fine, the browser will forward the message with the app ID, the challenge, and the origin to the token. So the token will generate a public key, a private key, and a handle edge. Once this has been generated, it will send to the browser back the public key, the handle edge, and the certificate, and the citation. The citation is the challenge encrypted by the private key. Everybody is aware of the concept of the public-private key in cryptography. So using the private key, it encrypts again the challenge. So this is a citation and the certificate. So the browser will send the certificate, the public key, and the handle and the citation back to the service. So the service will verify this and verify that the challenge is after decrypting the message using the public key, that this is the same challenge we started with in the first place. And then if everything is okay, then we will store the public key and the handle edge. So the question is, what is the handle edge? Any clues? These keys doesn't have memory. So there is no way I need to store the private key, right? To be able to do it again, I need to store the private key, but there is no memory inside. So the trick is very simple. There is a very small microprocessor that have random seed based on it's just burned on the chip at the manufacturing time. So based on the handle edge and the random which is inside, the key would be able to reduce the private key again.
And the combination of the
no, it is something derived from the private key to be able to guess it again. When I receive the handle edge for this key, I would be able to generate intermediate key. It doesn't work alone. It only will be able to work with this key. If I use this key, it will not be able to retrieve the private. Yeah, with the security key itself. So technically speaking, you have a fingerprint for the private key, but you don't have that as a server. You don't have the private key. It's on its own. You have the fingerprint of the private key. So you have to send it again to the security key. It will, using its microchip controller, it will be able to reduce the private key, so it will be able to encrypt and decrypt your messages.
So it's time the handle key.
No. Yeah, between every service it change. Every service, but for that registered service, it will never change. Because as we will see here in the authentication pipeline, here we will start by sending the handle, the application ID, and the challenge. So we are telling this key that this is the handle we are talking about. So the same phase, the browser will check that the app ID is the same as the domain, and if this is the scenario, it will send the whole message again using the handle, the application ID, and the challenge. Okay? So using the handle, the private key will be reduced. And then it will send the signature of the challenge and a counter of how many times we have logged in. This is a security feature that you can say how many times this security key have been used on our service as another. And so
every time you close a browser for that web application, in order to go back to that web application, you will need the key.
Yeah.
Every time.
Every time. If your session is not expired, if your session is still there, خلاص, no problem. You will be able to log in.
But if the browser is closed,
if you need to log in, you need to provide the key as well.
But Muhammad, if the attacker knows the handle edge.
The handle edge is not the handle edge. It will be a problem if you have the same security key, because there is a number inside nobody knows.
No, I mean if the hacker.
No, because nobody knows, even Ubico doesn't know the random number inside.
the random number.
There is a random number inside this one. If I use it, this is all the same. Each one of these have a random number inside which is different. So the handle with the random number, if you see the gates, the handle with the random number will generate the private key. Okay, so using the Here, after the signature is done, we received it on the server. We will decrypt it using the public key. If it is the same challenge we started with, then this is the security key the user has registered before. So life was easy. Why we needed the web authentication API? What was the challenges with the UTF protocol? UTF protocol was mainly designed by Yubico and Google. So Yubico at the end is a manufacturer. So it's benefit that the protocol was designed for these type of security keys. And at the same time, it was based on a JavaScript file, not as a browser API, which caused a problem since these mobile phones now has fingerprints, has iris scanners, and has face recognition. So I can just verify the user identity using his mobile phone. The user doesn't need to connect the security key to his mobile phone to be able to log into the service. He has his own sensors here and security and biometrics here. So that's why people started to work on what's called the web authentication API. And the web authentication API take it a step further. It's not about a second factor authentication. It's more now about passwordless authentication. The user shouldn't use his login with a password. Only for one time, register your security token, and that's it. You shouldn't use your password anymore. In the same time, authenticators will be the one responsible about identifying the relaying service. And you will see this in the demo. Because you cannot, if like Muhammad said, if we have the handle and we can just mimic the application ID, the security key will handle the private key. But now the authenticator will be the one responsible about validating, not the browser. So in the UTF protocol, the security key was trusting the browser to doing the validation. Now the authentication will do the validation itself. So how hot is the topic? The topic is very hot. This news has been like this just last week, that on the 6th of March, this has become a standard now. Microsoft has been the first company to work on this. All Microsoft services in November and December you were able to log in using your Windows Hello account. Just use your fingerprint on your laptop and you will be in without any password. So Microsoft was the one trying to push on this. So Microsoft pushed it in November, and now the standard last week has become a standard. So we are talking about standard protocol. So how this can make our life easier. So this is a demo that was done by Google.
Can you switch to the demo device, please? Suppose that I'm browsing the web and find something I want to buy. I have with me here a Pixel 2 phone with a fingerprint sensor. So suppose I have this camera cleaning kit that's really nice. That's a really good deal for just 10 cents. So I add it to my cart. Then I go to checkout. And then I choose to complete my checkout with PayPal. I get redirected to PayPal. And because PayPal supports the web authentication API, I can easily verify my identity using just my fingerprint. Sorry? Select the credit card, shipping address, and I get redirected back to the merchant. And there, my order is confirmed. So I didn't have to type a password, and it was still secure. It was so much better user experience.
So technically speaking, it's more secure because nobody would be able to get your access except with your own fingerprint. And it was much user experience because he didn't type a thing. He checked out without using the keyboard at all. So we will answer the question he was going to answer in the talk. So how all of this has been done. So This is the registration flow. It is the same, but there was some little details that's changing how these things work. So we will start at phase 0 here, that the JavaScript wants to register a new token. So the server sent a challenge, the user info, and the relaying party info. And then the JavaScript or the browser will send this information to the authenticator, who will ask the user to verify his identity and generate a new key pair, which is a public and private key, and signs the challenge we started with the private key. And all will be sent back as a new public key, the credential ID, and the citation will be sent back to the browser, which will be forwarded to the server, which will validate that the challenge we received using the public key and this is the same challenge that we started with. Before taking your question, Muhammad, what do you see different in the message sent between this model and the UTF protocol we discussed? هي ماشي, but هو there is a problem here that we said that the new key pair, because here is an authenticator which we don't know the type of the authenticator. There is another difference in the message sent from the server to the browser. Sorry? No, the relaying party info was a part of the, it's called the app ID. It happens in some cases because in the technology when this interface it will send the handle as well. So yeah, because here we have here the word authenticator, we don't have the word key. We have authenticator because the authenticator can be anything. It can be your Touch ID or your Mac. It can be your fingerprint on this Android device. It can be your security key. It can be your retina scan. So we have a standard to deal with the authenticator. We don't know what the authenticator needs to do. Any authenticator, any physical authenticator, but in the same time, nobody getting what is the difference in the message we started with? Because this is one of the most important steps. This is what caused all of this to happen. Not the private key, the user info. The user info is the difference. In the previous one, we sent the app ID. No, we sent the app at the start. We sent only the app ID and the challenge. See, in this slide, in the registration, we sent only the app ID and the challenge. Okay. Here, we are sending the app ID, the challenge, and the user info. And why this is different? Because, as we said, we need to go passwordless. In the UTF, it was only used as a second factor. As a second factor, which means that the system, that you need to log in with username and password first. I know this is you, so I just want to verify it is you. Here we are using this as the basic replacement to the password. So we need that authenticator needs to know that this account is registered to whom to be able to validate you. Use the username, the user ID, and this stuff. You just make it, but the most important field is the username and the user ID. So let's go with the authentication phase. So the authentication phase starts with the same that the browser wants to authenticate. So as the browser wants to authenticate, the server this time sends only a challenge. Okay. So the browser will send the challenge, and the client has data to the authenticator, who will ask the user to verify his identity and will send the citation back, the challenge encrypted using the private key, which will be sent back to the server, to the browser, which will send it to the server to validate the request. Okay. So it is the same. So how this is supported? Before this slide, can anybody tell me what is the newest or the latest version we are using in Chrome and Firefox? Nobody knows the answer. Which one? For Chrome or Firefox? I need both. Chrome is Chrome. No, Chrome is 72, and Firefox is 65. And we are saying that this support is like 6 months back. So we are We are discussing now a very, very hot topic. That some browsers, yani we are still just 6 months before this technology was not supported at all. And something that is very, very annoying that if you see that, like I always say now, that Apple is the new Microsoft. See, Safari doesn't support it either on the PC or the iOS. If you if somebody old like me, you remember that IE standards of the web were coming everywhere, and Microsoft was ignoring it in the Internet Explorer. So Apple is the new Microsoft. Safari doesn't support this technology as a web authenticator, and you cannot talk to the Touch ID directly. You can just use the
But you tested it online.
Mac using Chrome. Okay, so what we have said till now is very nice. How we are going to use this in our codes. We need to do it. This is very nice technology. We like to support it. How we are going to support it. So just go and start using the Django MFA2. The Django MFA2 is an application that handles MFA. It supports TOTP, UTF, and FIDO UTF, which is a web auth protocol. So you will see it, some people say it's FIDO UTF, which is the official name of the standard, and it's well known as the web auth protocol as well. It supports as well email tokens and trusted devices. Trusted devices is a mode that supports devices that have no fingerprints or doesn't support web authentication, like the iPhones and the budget Android phones. We will go and see this. So if you need to use the library, just feel free to start using it. So the question is, which authenticators is supported by the Django MFA2? You can use your security keys on Chrome, Firefox, Edge, and Safari. On Windows, Mac, or Linux. You can use your fingerprints on Android, but in Android, the network is called Android Safety Net, because in Android Safety Net, the user can use anything from his fingerprint, iris scanner, face recognition, even using his unlock code, PIN code. Or if you have a Mac with a Touch ID, you can use the Touch ID on Mac on Chrome 70 Plus. So let's have a demo about using this software. So let's start the demo. Okay, so first let's log in with one of the users which we created for the demo. Okay, so here the user have no second factor authenticator. We just logged with the username and password, and that's it. So let's start step by step. So we will go here to security, and we will say we need to add a new security device, and we will select now the FIDO security. Okay, so the browser now is saying that the device wants to authenticate you. So we will say proceed. And here, if somebody sees that the key is flashing, so I just press the key. So the registration is done. So here is the key edit. We have this type of FIDO UTF key, and it never expires, and it was never used before. So let's log out, and log in again. So let's say the username and password. Here it is. So now it's asking me to verify my identity. If I have to press the key. So now I'm logged in. Okay. But what about this phone? So let's move to the phone. Okay. So here is the phone. We connected to the same service. So we are logging with the same account here. Now it's asking me. So here, this is coming from the OS itself, from the Android phone. It's telling me this application needs to authenticate you, so please provide. This phone have a fingerprint, but does anybody know that? See that there is a fingerprint option here? No. Why? Because the authenticator doesn't know the service till now for this user. So that's why it doesn't give me, the only option is to use the Bluetooth one or to use an NFC one or a USB one. Okay? You can use the Bluetooth. But this one, which I have, has an NFC as well. So I can just do it like this. And here I'm logged in because this one has an NFC. Okay? So let's go do the fancy stuff and let's add our fingerprint. So I go back to security. Now we will see that, but it is a little bit small, that it's already been used. So here we will just, I cannot zoom in. So here, this is the same steps. We will say FIDO security key. Okay, now I'm getting this message again from the browser and it's telling me use your security key with a fingerprint. So I will check this option. Okay, so now the phone is asking me to verify my identity using the fingerprint. So I just put my fingerprint in. And now the registration is complete. So if I just log out and log back in with the demo account, now it's just asking me to authenticate using my fingerprint. So here is my fingerprint and I'm logged in again. Okay, so let's do the last thing out of this is Google Authenticator code. So we go to this service now, the one about the TOTP. So now if we log in, we found that we have two security methods. We have one as Android safety net and we have the other one as the FIDO2 with the black security key. And let's add the TOTP now. So we use an Authenticator app. So here is the code. We go back here to the phone and we will go to Google Authenticator. So let's open Google Authenticator. Here it is. And we will just click add new service and we scan the barcode and we just bring it here. And now as you see now it's the list one of them saying HGP demo with the demo user. So here is the code. So we will just write 066523. Let me see. Now the authenticator is added successfully. Now we have three services. So we can log out and log back in. And now we can join the demo account. That's it. And we will see that we need the Authenticator app. So let me write the code on your screen. So if we go back here, we will see that the code has been changed to 926.863. And we are back.
In case of using the key, you still have.
Yeah, this is the second message.
But then you have to have all these securities in place on that time.
There's some services like GitHub and Google have what's called the backup codes. So once you start using second factor authentication, you have to download this file, keep it in somewhere place, because in case you lose all your authentication methods, this is your last resort. Okay?
I have two questions.
Hmm.
The first one, can we go passwordless?
Yeah.
In this case?
Here it is. This is the answer of your question. We can go passwordless. Let me open go back to my phone. Here is the MDL app. Okay. Now, staying me, just provide your fingerprint. I'm logged in.
But the second question, what is the difference between and the personal password managers, like your LastPass?
That's LastPass. LastPass just records your username and password. Doesn't protect you against the problems with passwords. LastPass is just a recorder. It's just a data store for the username and password, right? So this doesn't protect you about your password being keylogged or your password being hacked or anything. No, there is a technical part. We are done with the user, but there is a technical part. I believe it's only a couple of slides. So how we do integrate Django MFA2. So we need to pip install the library. We add the MFA to the installed apps, and we add the package settings mentioned below. And the technical step is to break the login function into two functions. Because technically speaking, the login function is responsible about getting the username and password from the request, checking them against the database, and logging the user in by creating the session. So we have to change this a little bit. So the first function should be able to validate the username and password. Call has MFA helper function that either with the username, if false is returned, call your second function which will create the session. Like we in the first run time we tried the application, we just log in with the username and password because we didn't have any second factor authentication. So once I logged in with the username and password, it just pushed me through. So if something other than false returns, you have to return it as a HTTP because the has MFA returns either false or HTTP response redirect. So either it return you a false, so you can like here if REST is false, it will return login user in. This is the function which will create the login for the user. If it returned as a redirection, so we should return the redirection back to the user, so he goes to the MFA page. The second function would be responsible for creating the user session. It should take the request, the username as parameter. It should not be accessible from the URLs file. Because if it's accessible from the URLs file, anybody can log into any user. And